Okay, so this is your review sheet for your first test. You are able to use this when you take your test, so anything you write down will definitely be helpful to you. So make sure you're adding in and writing whatever you need. So the first thing that is on here is what we call real numbers, and real numbers are any number on the number line. And I always revert back to when you think of elementary school and you guys had a number line in front of the classroom, right? That's basically what a real number is. It's any number that you can see on there. So we can kind of narrow it down and be more specific and give the smallest set of numbers that we talk about counting numbers. And those are just basically numbers that you count with. So for example, when you count, okay, you start with the number 1 and so on. So I always say you don't start when you're counting the number of students in a room and start with 0. You start with the number 1 and you continue thereafter. You also don't say 1, 1.5, right? You just use those nice clean numbers when you're counting. So basically now whole numbers are the set of all my counting numbers, right, plus 0. So for the example for that, basically what you would do is you would take all of your counting numbers, right? And all you're going to do now is add in 0. Okay, so now we are just including 0. And the way I kind of try to remember that is in the word whole, I have that O, right? Which coincides with the extra 0 that we're adding now. So those are whole numbers. Okay, integers now are all of my whole numbers. So basically, those are all of my whole numbers. Okay, and now we're going to add in their opposites. So we're going to include numbers like -5, -4, -3, -2, -1. So it's all the numbers that previously existed from whole numbers, and now we're just adding in their, basically what we're adding in is negatives. Okay. One of the big things to notice about these three subsets of numbers here, counting numbers, whole numbers, and integers, so all three of them, is not a single one of them include decimals. So there are no decimals included when we talk about these three types of numbers, right? No decimals are included. So that's kind of important. Those decimals, however, they are still what we call real, or they're considered rational numbers, right? They are these numbers that still exist in the world of math. So all three of these sets of numbers are still real numbers, but we can classify them now as something called rational. And I like to think of rational numbers as numbers that make sense, right? But by definition, a rational number is any number that can be written as a fraction with two integers. So I can take most decimals and convert them to fractions, which allows me to then call them rational. So I kind of have broken them into 4 categories, which I think is a good summary here. The first one is a repeating decimal. So something is rational if it's repeating. So the number could look like 1.45454545 ... to show that it continues to go on. But the 4 and the 5 are continuously repeating, so that's rational. Something else, or another way to write this, would be 2.3, and then you could draw a bar over that 3, and that would tell us that it's repeating. So those are both rational repeating decimals. The next one would be something called a terminating decimal. So a terminating decimal means that it stops. So that could be 3.25, or it could even be something a little bit longer. But again, there's no ... on the end of either one of these, so it means that it stops. So the word terminating, just in case you forgot, means ending. It stops. Okay, next we have fractions. So all fractions written with 2 integers are considered rational numbers. So we could have 2/3, that's rational. I could have -5/6. Again, that's rational. Okay, they're fractions, but they're rational. And the last thing here is something called a perfect square. So a perfect square means that if I took the square root of a specific number, if I was to put that in my calculator, I would do second x squared and type in 16, and you'll notice that you get a nice whole number of 4. So that's called a perfect square because it just means that 4 times 4 gives us 16, which means that it's a nice number that can be written as a fraction. So although we have these nice numbers that either repeat, terminate, can be written as fractions or are perfect squares, we also have all the other numbers out there, which we consider to be irrational. So I always revert back to if you've ever been called irrational. So sometimes I remember being a kid and my parents would say, "You're being so irrational right now." And it just meant that I was being so, I wasn't making sense or I was being crazy in a way. So irrational numbers, they in a sense are crazy numbers that don't make sense. They are numbers that do not terminate. So this is key here. They do not terminate and they do not repeat. So a couple examples of those could be numbers like 0.89576 and so on. You would see the ... Or we could have something like 12.4875 ... right? So that ... tells us that this decimal goes on forever. And as you're looking at this decimal, there's no repetition. So they don't stop and they don't repeat. And the other thing here would be a non-perfect square. So something like the square root of 8. And again, if you weren't sure, you could always take your calculators out and you could do the square root of 8. And if you put that, you would get 2 points. So that gave us, 2.82842. So 2.82847, 8427, ... So your calculator screen does show that it stops because your calculator can't fit that many numbers. But if it fills the screen as it's doing here, you have to understand that it just can't fit anymore. It can't fit more than 10 digits. So it's going to fill up the screen. You're not going to see repetition. And that's how you would determine that it's a non-terminating and non-repeating decimal, which therefore is irrational. So remember, a nice easy way to remember this, and this doesn't work for an explanation on paper for the Regents, but it works here. It's a crazy number, right? These are crazy numbers that they just don't make sense. It's kind of my little trick, right? Whereas rational, I like to call them, they're nice, predictable numbers. So yes, sometimes they go on for a long time when they repeat, but they're predictable. Like I know what's going to come next year. It would be a 4. Okay, so now we're going to get into the properties. So the properties were kind of a big part of what we did last week. So first thing for the properties, commutative comes first. That means we are changing order. And the way I remember this property is I use that CO in change order. And that's what commutative starts with, CO. So if I wanted to give an example of this, I could do 2 plus 3 is equal to 3 plus 2. I'm changing the order of the numbers. Or I could do 4 parentheses 2, and we're going to do times here. All right, we'll use the dot. I don't know why it's not going in. So 4 times, and then we'll just continue typing. 3, and that's going to be equal to, let's say I keep the 2 and the 3, right? 2 times 3, and we moved or changed the position of the 4. Right, so the 4 was in the front here, and then it changes to be in the back. That's the commutative. I changed the order. So the associative says that we can change grouping. And for this one, I think about grouping being friends. So you have 3 friends, they're all best friends, right? But throughout the day, for school, let's say they're grouped differently. So let's just say that Al and Bob have lunch together, and poor CJ, their third friend, he's in math all by himself that period. And then the following period, Bob and CJ have English together, and poor Al, he's in science all alone. So with that, you're just changing the grouping. So let's just say for that we did 5 plus 2 in parentheses with a plus 3 on the outside, and we set that equal to, and now we're going to say, okay, well, the 5 is outside and the 2 and the 3 are being added together first. So here, the big key here is that 5, 2, 3 is equal to 5, 2, 3. The order does not change. So that's one of the big things. Order doesn't change. Only the parentheses and what's grouped together do. Okay, the distributive property we talked about last week, and we just spent a full day on it this week. So the distributive property says that if I have an element on the outside of a parenthesis and I want to get rid of those parentheses, I can do what we call distribution. And I'm going to write the answer, and then I'm going to show you how we get that. So what you would do is you would take this term on the outside, that 2, and it's going to be multiplied into the parentheses. So 2 times x is how we got this 2x here. And then the second distribution would be 2 times 3, which is how we got this 6 here. One of the key things to recognize the distributive property is that you are getting rid of parentheses. So if a question says to you, how did so-and-so solve this problem? What property did they use? And if you're looking at it and you're telling me that the parentheses are now missing on the right side, then it most likely is the distributive property. So the 0 property, actually, this is a property that you all know. I'm not positive it was in your note packet, but it is a property that you guys have talked about. And all it says is that when you multiply by 0, your answer is 0. So this is that rule that anything times 0 is 0. So if I have 234, right, times 0, the answer is just 0. Anything times 0 is 0. Okay, our 2 identity properties. So the first identity property says, for addition, that if I add 0 to any number, so let's say we do 4 plus 0, that the identity of that original element, that 4, stays the same. I don't change its identity. Okay, that's the identity property of addition. I'm adding something to 4, right? And I'm getting 4 back as an answer. So for multiplication, what number can we do this with for multiplication? And that would be multiplying by 1. So again, if I took the number 4 and I said, okay, well, I'm going to multiply it by 1, the identity of that 4 does not change. So this is keeping its identity the same. Okay, so the next 2 are your inverse properties. And remember that word inverse means opposite. So when we talk about adding, it's a little bit easier to understand. So with adding, if I started with, let's just say, positive 4, its opposite would be negative 4. And when I add opposites together, I get an answer of 0. With inverse property of multiplication, you are actually dealing with what we call a reciprocal, which means that we flip the fraction. So let's say I start with the number 3, because typically we do start with regular whole numbers or integers, right? 3 is currently not a fraction. So there is a way, though, when you're dealing with numbers like this, that we could take any number, like the number 3, and if I want to make it a fraction, I can always put it over 1. So now when I take the reciprocal of that, I am going to flip and make it 1 over 3. So 3 and 1 over 3, they are reciprocals. Let's just say I had -2 over 5, right? If I flip that, it would be 5 over -2. So these are reciprocals. Okay, so next is my equality properties, and those are the properties we talked about on Friday. So the equality properties state that any operation performed on one side of the equal sign must be performed on the other. So it sounds kind of bizarre, but what this is saying is that if, let's just say we were going to solve this equation, x plus 2 is equal to 5, right? And then I gave you the answer and I said, oh, well, you know what? This is what I got as an answer. And I said to you, well, what property allowed me to get that as an answer? And how did I get that answer? So if you just look at the work, how would you solve an equation like x plus 2 equals 5? Well, when you solve an equation, your goal is to get this x alone, and you would have to move this plus 2. So to get rid of a positive 2, I would subtract 2 from both sides. So again, what I did on one side, I had to do on the other. So here it cancels, which is why we're left with just x, and then we did 5 minus 2 to get 3. So the property that's used here, we just call we subtracted. So it's the subtraction property of equality. So again, let's say I was multiplying on both sides to solve it. Then it would be the multiplication property of equality. If I was adding, it would be the addition property of equality. And if I was dividing, it would be the division property of equality. So these are your equality properties. Okay, so now we get into these practice questions, which some of these are basically identical to what you're going to see on your test. So number 1 says which expression results in a rational number. So we're looking for which answer gives us a rational, which choice gives us a rational answer. So this I would use my calculator for. So remember, when you're typing this in the calculator and you want to put more than one square root in, you have to use those arrow keys to close it out, and then times the square root of 18, and we get an answer of 6 for number 1. So the answer of 6 for number 1 is actually our rational answer. It's a whole number. It's a counting number. So choice 1 is actually our answer for number 1. So we don't even have to keep going. Okay. Number 2 says when solving p plus 5 equals 6x minus 8, Alex wrote p plus 13 equals 6x. The property he used is, so this is kind of exactly what I was talking about in the equality properties here. So the way I would do this is I would rewrite the equations. So start with p plus 5 is equal to 6x minus 8. And underneath it, put the second part, which is just p plus 13 is equal to 6x. And then what I would do is look at what's different. So when I'm looking at this, I'm looking to compare and see what's changed. So here on the left side, I can see that the 5 changed to a 13. And then I can see that I had a minus 8 and now it's gone, right? So I have to think in my head, how would I get rid of or make this minus 8 disappear? And the way that I could do that is I could add its opposite, right? If I add 8 here, it does allow me to cancel. Well, the equality property says that what I do over here, I have to do over on the other side. So if I add 8 again, 5 plus 8 gives me that 13. And what did I do? I added. So it's the addition property of equality. Okay, number 3, which expression results in an irrational number? So now I'm looking for an answer that gives me that crazy response in my calculator. So again, I'm going to put these in my calculator. So to put a fraction in our calculator, there's 2 ways to do it. We could do it with division, or we could use alpha y equals and hit enter. And you'll physically see the fraction now. So we're going to do 4. And then the pi symbol, we hit second caret. And then we're going to hit second caret again. And for number 1, we get an answer of just 4, which is rational. So that's not my answer. Number 2 says the square root of 6 squared. Okay, again, that's a nice number. That's 6. So that's good. I mean, that's not my answer. I'm sorry. Number 3 is the square root of 18. And that we get this crazy decimal that kind of goes on forever. So it's 4.2426. So 4.2426, and it goes on forever, right? It fills that screen. So that's my non-terminating and non-repeating decimal. So choice 3 would be my answer. Okay, choice 4, just to look at it, it stops. There's no ... here, so that's why it's not irrational. Okay, number 4 says which statement is not always true. So you're just reading through these carefully and seeing which one is not true. So not true means false. So I'm looking for the answer that is going to be false. So the first one, the product of a rational number and an irrational number is rational. So you could always try these, but a rational number, we'll take our calculator. Let's just pick 4. Keep going with 4. So 4, product means multiply. So 4 times, let's just do pi, because pi is an irrational number. And we get an irrational answer. We get this crazy number back, right? So they're saying we should get a nice answer, which if you read carefully, that's not true. That's false. So we don't even need to keep going. If we wanted to read through our answer choices, choice 2 says the difference of 2 irrational numbers is irrational. So that's saying taking 2 crazy numbers, subtracting them, I'm still going to get a crazy answer. And that's true. 3 says the difference of 2 rational numbers is rational. So the difference, again, subtracting 2 nice numbers, I'm always going to get a nice number back. That's also true. And 4 says the sum of 2 irrational numbers is irrational. Again, that's always going to be true. Okay, so number 5 says state if the following are rationally rational. So again, we're using our calculators here. So for here, you have a lot of fractions. So to do a fraction, again, I'll jot it down here. We do alpha y equals and then enter. And that's how we can kind of enter in a fraction. So I'm going to show you guys here. So we have alpha y equals enter, and we're going to type in -5, arrow down to get to the bottom, 8, and then it's plus, and we're doing another fraction, alpha y equals enter, 3/5. So that's -1/40. Okay, and that's a rational answer. Okay, remember any fraction with 2 integers is rational. So that's a rational answer. Okay, number 2, 1/2 plus the square root of 2. So we're going to do alpha y equals enter and do 1/2 plus the square root of 2. And that gives us 1.9142. So 1.9142 ... And that's going to be irrational. That's a number that does not stop, does not repeat, goes on forever. Okay, the next one, the square root of 5 times the square root of 5. Again, we're going to use our calculator. So second x squared for that square root. Arrow out to close it. Times the square root, again, of 5. And that gives us an answer of 5, which is a nice number. It's rational. And that last one, we're doing 3 times the square root of 49. And we get a nice answer of 21, which again is rational. Okay, so number 6, given that L equals the square root of 25, M equals the square root of 64, N equals 2 square root of 7, and P equals the square root of 5, which expression results in a rational number? So we're looking for the answer that gives us a nice answer back. So let's try the first one, L plus M. Well, they told me L was the square root of 25 plus M, which is the square root of 64. So I'm going to, again, type this into my calculator and see if I get a rational answer back. So the square root 25, notice my arrow is blinking, so I have to kind of push out of that. Plus, now, second x squared again, 64. And I get an answer of 13. So 13 is a nice rational number, so I don't even need to keep going. That would be my answer. Okay, if this did not end up being rational and it was irrational, I'd have to try the next one. Okay, number 7 says, given the following work, find the mistake and explain what they did wrong. So hint, look between lines 2 and 3. So if I focus only on lines 2 and 3, I want to compare them. And what do I notice? I notice that I started here with parentheses, right? And now it looks like they're gone. Okay, so what did they do? So if we took that 4 and we distributed it, we would do 4 times x, which is 4x. And then if I did 4 times a -1, I should have gotten a -4 here. So what did they do incorrectly? They did not distribute. To both the terms in the parentheses. And that's their mistake. You have to distribute to all terms inside the parentheses. Okay? And the last one here, the product. So product, again, means we are going to be multiplying. So we're going to multiply the square root of 576 and the square root of 684. So let's try it. So second x squared, 576. And we're going to arrow out and multiply the square root again of 684. Hit enter. And we get an irrational answer. So when we multiply them, we get 627.681, ... right? It goes on forever. So we get an irrational answer, which makes me eliminate choice 2 and choice 4. Now it's a matter of figuring out why is it irrational. This first choice says that both factors are irrational, meaning that both of these square roots are irrational. So let's figure it out. So if we do them individually, the square root of 576 is 24. Well, right off the bat, that's not an irrational answer. That's rational. It's a nice whole number. So only one, let's try the other one, the square root 684 is irrational. So only one factor is irrational. It would be choice 3. Okay, guys, so that's the last question on the review sheet. Please make sure if you at any point you didn't understand anything that you email me, or please come to Extra Help this week, Tuesday or Thursday at 1:30. If you have any other questions and you just want to email me and ask, you most certainly can. Rewatch this video before you go to take the exam, and you may use the review sheet. So anything you write on that review sheet can be used when you're taking the test.